So I put in my first angle, which would be 0. And I take the sine of 0. And so on your unit circle, the sine of 0 degrees is 0. And so as you can see, the first point on our graph is 0, 0. So at that point, the dolphin is right here. Now I don't know if he's going up or if he's going down, but he's right there, right at the water level. So I'm going to move on. I'm going to move over to 45, or as I have it labeled there, pi over 4. All right. So now I'm taking the sine of pi over 4, or 45, which according to your unit circle is root 2 over 2. We can find a decimal for that. And the decimal for the square root of 2 over 2 is 0.7. Okay, well, remembering our scale vertically, 0.7 is about right there. Then we move on to the next angle, which is 90. So we have the sine of 90, which is 1. And at the 90 degree mark, we are up at 1. $135. I'm going by 45 degree increments here. The sine of 135 is root 2 over 2, which I know from 2 angles ago is 0.7. And then I go to 180, and the sine is 0. So look at our dolphin. He has gone out of the water and reached a maximum point, and now he is diving back into the water at 180 degrees. Okay, now at that point, does he go back out of the water? Is that what dolphins do? No, he's going to dive. He doesn't bounce off the water. That'd be a neat trick. So we're going to go to the next angle, 225, and the sine of 225 is negative root 2 over 2, which is negative 0.7. And we just continue on. 270 would be negative 1. 315 is negative 0.7. And 360 is 0. So you can see there, we are back to the dolphin leaving the water. So what we've done is we've completed one circuit of the dolphin's behavior. He's up, he's down, he's back up. So that's basically a rotation. And now he just repeats it over and over for miles. And that's what this graph would do. You would just take this little piece and paste it both ways, and you've got the whole graph forever. Like that. Okay? The key is getting that one circuit, that one section where that dolphin's doing whatever he's doing right, and then the rest is just repeating. Okay? That section is called the period of the graph. Okay? The period is how long it takes the dolphin or the graph to get back to where it started. So if we look back on the graph, the period is how long it takes this purple line to get back to this position where it's rising through 0? Okay, so it's rising through the water. It's shooting out of the water at 0. When's the next time that happens? 360. So the period of the graph is 360. You could think of it as a distance or a length of a time, but it's in degrees, however you want to think about it. That's the period of the graph, is the length or whatever of the one circuit of behavior of the graph. Okay? So let's try another one. We're going to graph y equals cosine 2 theta and state the period. So we're going to do it the same way. Make a theta y table. This one's a little bit different because it has a 2 in front of it, the angle. So before we take the cosine, we have to multiply it by 2. So our first angle is going to be 0. We multiply by 0, or we multiply 0 by 2, sorry. 2 times 0 is 0. And the cosine of 0 is... Don't guess. The cosine of 0 degrees. 1. So on our graph, we go to 0, 1. Okay, if you do not know what the cosine of 0 is, maybe you should have your unit circle out. Now we move to 45 degrees. First thing we do is multiply it by 2. 45 times 2 is 90. Then we take the cosine of 90. What is the cosine of 90 degrees? 0. So at 45, we are at 0. Just making an XY table, kids. That's all we're doing. Now we move another 45 degrees to 90. Multiply it by 2. It's 180. And the cosine of 180 degrees is -1. So our dolphin is taking that path in this problem. A little more adventurous than the last one. Let's move on. 135. 135 times 2 is 270. And the cosine of 270 degrees is 0. The next angle, 180. Multiply by 2, 360. And the cosine of 360 degrees is 1. So it looks to me like our dolphin has repeated its behavior already. Right? Down and back up. What else is it going to do? That's it. So within that short span, that dolphin has done everything it's going to do. So you can actually just start repeating the circuit like that. You can then go backwards and repeat it. And now you just draw a line. So there's the graph. The period of that graph is how long it took to make that V. How many degrees did it take to get from one point to the other. It doesn't necessarily have to be from 0 to whatever. It's wherever you want it to be. The period should be the same no matter where you start. And it looks to me like it's from there to there, top of the V to top of the V. You could have done bottom of the V to bottom of the V and got the same exact answer. Looks to me that is 180. 180 degrees to get from one point to its matching point on the graph. All right? So there's a couple of formulas for period and amplitude. You don't even know what amplitude is. Amplitude is the height, basically. How high is the dolphin going out of the water? So the height of the dolphin from water to apex is the amplitude. It's defined on the screen as half the distance from the top to the bottom. That means the same thing. So you can think of it one of two ways. You could take the entire graph, like this one, measure the distance from top to bottom, and cut it in half, like so. Or you could just think of it as the distance that the dolphin is leaping out of the water, so from water to top. It's the same exact thing that I'm talking about, okay? So the two that we've done so far, the amplitude for both of those is 1. The height's been 1. The dolphin has gone up 1. Those two graphs. Why? Because when you look at a trigonometric equation, and here are the general ones, y equals a sine b theta, and y equals a cosine b theta, the amplitude is a, or the absolute value of a. Since we're dealing with a height, it has to be positive. And both of those were 1 in the examples we did. The period of a trigonometric graph, for sine and cosine anyway, is 360 divided by b, absolute value b. It has to be positive as well because it's kind of a distance as well. The length from here to there. You do get a formula sheet in this chapter. I just haven't copied it yet. And I believe the amplitude and period formulas are on there for you. So, do this problem. Find the amplitude and the period of that graph. You don't have to graph it, just find the amplitude and the period. The amplitude is A, absolute value of A, so that's 3/8. Period is 360 divided by a half. That should be 720. Not 180, it's not 360 divided by 2. It's 360 divided by a half, 720. So that dolphin is really taking a long time. It's a long jumper as opposed to a high jumper. Okay. Last thing I want to do today is I want to graph this one, and I want to graph it not by using a theta y table, but by using common sense with the amplitude and the period. Okay, so I want us to start to get a feel for graphing it without robotically finding point after point after point. I want to start understanding. Okay? So, we have this equation. First, we want to find the amplitude of the equation. Can anybody tell me the amplitude of this trigonometric equation? Yes? It would be 1/2. Now, what that means is that this dolphin will never go higher than 1/2 on our graph. And as you know, that's only one line. So I'm going to draw that on my graph before I even make the graph. So my graph is going to be under or within those two brown lines. The amplitude's a half, meaning he's going to jump a half out of the water, and he's going to dive a half under the water, is what that means. Okay? So my graph's only going to be there. Now, the period of this graph is what? Can you tell by looking at the equation? Gritch? It's 360 degrees. So it's going to take 360 degrees for this dolphin to do its thing. So what I'm going to do is I'm going to mark that off. I'm going to stake out 360 degrees. Well, that's basically right there. I put a dotted line at 0. I counted out by 45s to 360 and put another dotted line. So within that little box of brown and pink lines, our dolphin has to do one trick, one circuit of its behavior. The key is, what we have to find out is where does he start? You know, when is he at the bottom? When is he at the top? Because that's what we don't know. So to do that, we're just going to put in an angle. I'm going to put in 0. When I put in 0, I get the cosine of 0, which is 1, times a half is a half. So at the angle 0, I am at 1/2. So at the start of our graph, on the y-axis, our dolphin is in mid-flight. Here's what that means. That means at the end of our period out there, on the other pink dotted line, our dolphin should be in mid-flight. Because those two pink dots, at the start and the end of the period, should be the exact same. Because they're going to be, when you copy and paste that thing on top of itself, those two dots are going to be right on top of each other. Okay, so let's think. What is our dolphin going to be doing at 180 degrees, you think? At the bottom. He's got to get to the bottom sometime. So he's probably going to be at the bottom, as far away from being at the top as possible. Remember, everything has to happen between the two pink dots. He's got to hit the top, hit the bottom, and go back up to the top. What about 90 degrees? Where do you think he's going to be at 90 degrees? Probably in the middle there. 90 and 270. I think we've got enough to draw it. Now, dolphins do not swim in herky-jerk V motions. They swim in nice, beautiful curves. And I added another one there just for closure. But there's my graph. Didn't need a theta y table. All I needed was amplitude period, and I needed a starting point at 0. Then the rest I just kind of figured out on my own.